changing technological world, and we all seen that what is that innovation happens across the technological fronts, and investment of the technology into the technology make the innovation exponentially high speed. In this last 100 years only, we have seen that all innovation, what about that power, electricity, thermal to gas and to then renewable energy, and now we are entering to that era of fusion cell. So innovation and getting this fire and to get the energy to all of the electricity and its journey that you are knowing quite well and better than me. But what is our role today? Sometime as a head of the institute, what exactly I am feeling, हम लोग कभी कभी वो वीडियो देखते हैं कि डॉक्टर के पास वो पेशेंट जाता है एंड देन डॉक्टर इज सेइंग डोंट वरी, so nurse is saying to doctor that you don't worry, doctor is saying that it is my first operation, so what will be the position of the patient? So while making debate with myself, sometimes I am thinking that what we are teaching you all today, how much is relevant tomorrow in this fast changing, and the topic what is most discussed today among the teaching fraternity is the half the age of the knowledge. Half the age of the knowledge is reducing so fast and so aggressively. So what we learn today, what you are preparing, the term work, summation, examination, grade, CPI, SPI and all, how much will be useful tomorrow when you are going out of the campus? So my worry is not only I am keeping that worry with me, but we are discussing among our all fraternities, faculties and all, that what is our role today. And when we are taking lot of input from across the globe, when participating at our level debate discussion, what is the skill or manpower or workforce requirement? We Indian are normally looked as that workforce, not only for our country but for other country too, and that we want to queue ourselves on a line कि हमको जॉब मिल जाए, अच्छा पैकेज मिल जाए. तो मैं कभी कभी यहाँ पर एज अ प्रिंसिपल बैठ के डिजाइन भी करता हूँ that what I am saying, it is a concise group of electrical engineering department only. Someone is coming and taking my students with some low wages, low salary. पास वाले को, मेरे पार्टनर को और रूममेट को 6 लाख का पैकेज मिल गया, तो मुझे भी 6.5 लाख का पैकेज मिले या 5.5 का मिल जाए, मैं भी निकल जाऊँ. So this is, I think it is we are at the end of such kind of the activities of placement in our colleges like VGEC, Viksit Bharat and Atmanirbhar Bharat. We will do that. That you and me have to make this all to happen. Everything will be surplus tomorrow, well researched out. There will be a surplus power, there will be a surplus food, there will be a surplus money, and most importantly there will be surplus time. ये आप चैट जीपीटी को पूछो तो बताएगा 2035 में बहुत कुछ अवेलेबल होगा. So what is our role as a energetic young engineers? Dear students, listen to the eminent person. We were talking 1 hour, हम लोगों ने बात कर लिया पूरा. साहब ने बताया कि हम लोग यूएस में गए थे, फिर यूके में, फिर सिंगापुर में, उनकी पूरा अक्रॉस द वर्ल्ड sir is moving and having vast experience. And US is a dream for many. Hardly we able to see even their gates. So when sir is here, listen each single word, and it is my experience from this profession. कभी कभी एक सेंटेंस सुना हुआ किसी की लाइफ बदल देता है. कहीं एक पॉइंट भी आपको ऐसा मिल जाएगा that you will take if that point onward, you will change your what is the think process or your career path. So once again, sir, I am welcoming you from the VGEC fraternity and institute, and very best wishes for the students. Take sufficient part in debating and question answer. Thank you.
Thank you very much, sir, for your inspiring words. With this, we now move into the most anticipated segment of today's program, the technical session, where we will gain a deeper insight into rapidly evolving domain of electric vehicle fast charging technologies. For this, let me introduce our esteemed speaker, Dr. Sanjib Kumar Panda. Dr. Sanjib Kumar Panda received BE degree from South Gujarat University in 1983, MTech degree from IIT Banaras Hindu University Varanasi in 1987, PhD degree from University of Cambridge UK in 1991, all in electrical engineering. He was the recipient of Cambridge Nehru Scholarship and M.T. Mayer Graduate Scholarship during his PhD study. Since 1992, he has been holding a faculty position in Department of Electrical and Computer Engineering, National University of Singapore, and currently serving as an associate professor and ex-director of the Power and Energy Research Area. Dr. Panda has published more than 530 peer-reviewed research papers, co-authored one book, contributed to several book chapters, holds 10 patents, and co-founder of 3 startup companies. His research interests include high performance control of motor drives, power electronic converters, condition monitoring, predictive maintenance, building energy efficient enhancement, net zero energy transition, etc. He is serving as an associate editor of several IEEE transactions such as power electronics, industry application, energy conservation, emerging and selected topics in power electronics. He has served as chair of IEEE PELS Technical Committee, Energy Access and Off-Grid System from 2021 to 2023. Dr. Panda is also serving as Membership and Chapter Development Coordinator for IEEE PELS since 2016 till date. Dr. Panda has been elected as members at large for IEEE PELS from January 2025 till December 2027. We are extremely fortunate to have him with us today to share his insight and expertise. Now, I request Dr. Sanjib Kumar Panda to kindly take over the session without any further ado and deliver the distinguished lecture on EV fast charging and discharging. A big round of applause.
Lights.
All right. Can you hear me in the back? Okay. Thank you. Thank you for coming and attending my talk. I don't feel comfortable staying at one place, so I like to move around. Unfortunately, I forgot my slide mover. So you can take a chair, sit down. So this is my talk. We cannot switch on. No, that's the normal sunlight here. Okay, that will be my presentation talk. But can you move to the next slide? So there are about 3 or 4 parts. The first part is introduction to IEEE and PELS, PELS, which in short we call it. IEEE, how many of you know or have heard about IEEE? Raise your hand, students especially. What does it stand for?
Institute of Electrical and Electronics Engineering.
Yeah, somebody else told me what it stands for. I was somewhere in 2014 in Amsterdam, and we are organizing an IEEE event there for the whole world. And this was one of the Israeli industry person. He told me while we are having a food dinner party in a small community of about 6 people, the organizer. Do you understand what IEEE stands for? I said that, are you making a joke or what? No, everybody knows IEEE. He said that no, not that IEEE, but the other definition of IEEE. I said that no, I don't know. Then he told me IEEE stands for I, eat, and eat, and eat. Honestly speaking, I don't know in India, but in Singapore, yes, knows about it. All the rest of the world, whenever you have an IEEE event, we all academics are volunteers. We are not paid by IEEE. We are volunteers. So one way of IEEE repaying back for our volunteerism is to provide a lavish food. And that is why he said that in IEEE event, you must be eating and eating and eating. That's the joke side of it, but that is indeed true. All conference we organize, all IEEE event we organize, at least in Singapore context and the rest of the world I have been, you get plenty of food. Nobody will get hungry without a food. I don't know in today's event, but in other events. So, IEEE is a professional organization. Go to the next slide. No, next, yeah. It is a not-for-profit organization, society. And do you know how many members are there of IEEE worldwide? We have crossed 2 months back the borderline of 500,000. So we are 500,000 plus IEEE members in more than 180 countries worldwide. You come to India, there is an IEEE. You go to Singapore, there is an IEEE. So more than 180 countries, IEEE organization, physical presence is there. So when you are becoming a member of the IEEE, you should make your chest wide, saying that I am an IEEE member. You will get the due recognition for that. It is a professional organization. जो बोलते हैं ना कि नौकरी करने के बाद, I don't know in what you call, in Singapore we call you have 5C, car, country membership, condominium और क्या कहते हैं. So it is like you are a member of IEEE means you belong to that category. So those of you who are not member of IEEE, I would encourage you join IEEE. And if you are a member of IEEE but not a member of PELS, you join PELS. I'll tell you at a throwaway price. IEEE, that 500,000 plus members, they have different interests within the electrical and electronic engineer. So we divide the IEEE into 39 silos. We call each as a society. There are 39 now. In a matter of year or few months, there will be a 40th society. That will be IEEE Transportation Electrification. Okay? That will be the 40th society. So 39 societies are there. And within that, PELS, Power Electronics Society, is one among the 39. And it is one among the top 10, about 7 or 8, in terms of the membership. Okay? So, sorry, can you go back? Yeah. IEEE Power Electronics Society was founded in 1987. It is not that old, 25, about 40 plus years. And to form a society, first you need to form a council. So like the technical transportation is a council now. So after 1 or 2 years in a council, it becomes a society. Okay? I will come to that technical electrification, transportation, that society in a minute or two. So PELS has about 14,000 members worldwide, and I'm a part of the Region 10. IEEE is divided into 10 regions. Now I think they're changing from 10 to 11. The Region 10 was so big that they are splitting it to Southeast Asia, I mean China, Japan, Korea, all those things separately, India, Pakistan, Oceania. This is the other Region 10. You won't believe, out of the 14,000 members, Region 10, which I head, we have more than 50% of the membership. Out of the 10 regions, Region 10 itself has more than 50% membership of the IEEE society. So it is the fastest growing, and they are looking at it India with people like young people, talent in electrical and electronics engineers. So the society has put on the red flag to promote in India and have presence felt in India for the Power Electronics Society. I was talking to Priyas, organize conferences and events so that you can bring it back a conference to Ahmedabad. Ahmedabad is so well connected international level bring the world expert to Ahmedabad so that students, staff, faculty member can interact. And the society president has given a high priority to India. Of course, China is also working hard in the same direction, but India has a positive part is the language. We speak English, so language barrier is not there, which is what is there in China. There is a problem. But anyway, so we will be developing it more. Our goal was given that by 2025, in hardly another 8 days, to make the membership to achieve 15,000. Unfortunately, we are not able to reach 15,000 by 2025. We are somewhere 14,000 plus, maybe 14,500 by the end of this month. We'll be shortage of about 500 members. But this event is one. If you act on it today, we will be fill that gap. We'll give you free membership on that one. Next slide, please. So this is the transportation electrification community. That is what I was talking about. The council has been formed about a year back. That will be the next society, okay? Because it has grown to be a society now. Now, if you look at the picture, the present transportation system is not sustainable. I'll talk about that in a while. So about 15 to 20 years back, the 4 societies out of the 39, we call them as sister societies because they are linked. Power and Energy Society, Power Electronic Society, Industry Application Society, Industrial Electronic Society. So this talk is sponsored by the Power Electronics Joint Chapter, Industrial Electronics, Industry Application. So the 4 societies, they came together about 15 years back, 2010, and realized that the present transportation system is not sustainable. And that should be a paradigm shift in the transportation sector. Transportation sector on the roads, you have already seen it. Hybrid cars were introduced by Toyota Prius, Nissan Leaf, somewhere in 1997, around there. So we have already seen 25 years of hybrid cars. Can you tell me why hybrid cars are better than the internal combustion engine car? Is it better or it is worse?
Yes, better.
Why it is better?
रेंज इंक्रीज हो जाती है.
Range?
मतलब अगर
हाँ बोलो हिंदी में बोलो.
अगर हमको ट्रैवल करना है तो हमको फिक्स ट्रैवल में अगर हम सिर्फ फील्ड से ट्रैवल करेंगे तो कम ट्रैवल कर पाएंगे. अगर हम 2 चीज़ों का यूज़ करेंगे तो ज़्यादा ट्रैवल कर पाएंगे, रेंज इंक्रीज हो जाएगी.
Okay.
Efficiency of motor is
Higher.
efficiency ज़्यादा होती है मोटर की एज कम्पेयर टू आईसी इंजन, बिकॉज आईसी इंजन में हीट लॉसेस में 30 to 70% एनर्जी चली जाती है.
तो आईसी इंजन का एफिशिएंसी कितना है?
आईसी इंजन का एफिशिएंसी 30 to 40% के आसपास है.
हाँ, और मोटर का?
मोटर का 80 to 90 के बीच में है.
80% का मोटर बनाओगे कोई खरीदेगा नहीं. Yeah, you are right.
90 के वो
Electric motors, anything more than few kilowatt, would have an efficiency of 90% or higher. And if you go at megawatt level, the efficiency goes to 95 plus. Okay? IC engine is about 30%, not even 40%. 30% is the most efficient point of the IC engine. So, are you all electrical student here, right?
Yes, sir.
Anybody mechanical? No, right? आपका principal civil engineering है, mechanical नहीं है. So I used to tell my student that mechanical engineers design IC engine about 100 years back, okay? And अब तक उनका efficiency 30% तक improve किए हैं, उसके beyond नहीं है. Electrical engineers design transformers and motors or machines 100 years back around the same time. But they worked hard to bring the efficiency plus. 3 times more, 30 to 90, 3 times more. You tell me whether you have done the right thing by choosing electrical engineering or should you change to mechanical engineering. That's the point. Mechanical engineering, not so efficient. Electrical engineers, people are very big. Whatever they design, 90 plus, वो 80% में कोई खरीदेगा नहीं आपका मोटर, वो बैकलॉस हो जाएगा तुम्हारा कंपनी। मिनिमम नहीं, उसको maximum. We go by the maximum efficiency, 95 plus. So, on the road, the question you answered is called fuel economy. If you take a IC engine, like I drive a Toyota Camry, IC engine, its fuel economy is about 10 kilometers city driving per liter. If I take a hybrid Camry, when I bought the car was 10 years back, nowadays hybrid Camry is that the fuel economy would be about 22 to 24% per liter. So it is increased by 2.4 times, same thing, range increase. Or you can say it is a fuel economy to be more correct. Okay? So that is because of the hybridization of the thing. I'll ask more questions, mainly for the student, to see your knowledge, okay, about this efficiency calculation. So it is 2.5 times more fuel economy, and therefore transportation electrification, hybrid cars are preferred. Hybrid cars are there already for 25 years. Now the next thing is we are having full electric car in the last 2-3 years. Cost is high, but it is going to come. Okay? In Singapore, we buy a car. Car is a luxury item. You won't believe how much it costs. You buy a Camry car. Now, you can keep the car for 10 years and cost is 250,000 Singapore dollars. Singapore dollar to Indian rupees is 70:1. Let's not talk about conversion ratio. It's not a time to speak about it. We have lost it. US dollar to INR has crossed 90. I never thought it was 84, 85 few months back. I never thought that it will cross 90. I don't know. Modi ji क्या कर रहे हैं? आप गुजरात के हैं, so he must have something in his mind. But anyway, so the cost of the car is very high. Okay? To keep it for 10 years, because out of the 250,000, almost 130,000 today's rate goes to the government as a tax. Just because you own a car, I have to provide the road. So the transportation mechanism is taxable to the car owner. So by 2040, there will be no more internal combustion engine car in Singapore. The government has already announced it more than 15 years before the deadline. That means a new car bought in 2030 will have a 10 years time. After 2030, you cannot register an internal combustion engine car. Are you getting my point?
Yes, sir.
So when you get new electric cars, you need charging stations. And we will have 60,000 charging stations by the end of 2030. 60,000. Singapore कभी गए हैं आप लोग? Some of you might have been. It's a tiny city-state country. The area is about 520 square kilometer. Width-wise is about 70 kilometer. Height is less than 30. Roughly about 525 to 575 square kilometer. हम लोग के पास लैंड नहीं है. इंडिया में इतने लैंड है, इधर जाओ उधर जाओ, जमीन है, उधर जमीन नहीं है. You cannot grow horizontally. You can only grow in Singapore vertically up या फिर vertically down, क्योंकि लैंड उतना ही है. और इस पीस में एक 1 story हाउस है, उसको तोड़ के property owner they build 100 story high. So I can have a 100 story building in the same piece of the land. Okay? So land is premium, and I'll speak about that a little bit later. So not on the road, even in the sea, the shipping and all these things, they work, the propulsion is based on IC engine. Okay? All the global transportation is through the containers and all those things for shipping. So that also is going to change to be electric propulsion. Okay? And not just sea or the road, even in the air. We are not yet ready, but the big Airbus, Boeing, they are still internal combustion engine, but in future it will be changed into electric, maybe 15 years, 20 years down the road. But you won't believe, air taxis are there. You can see it on the video. Air taxis, नहीं तो जो Uber taxi नहीं है, air taxis, 4 passengers can get in, autonomously you drive in the air to reach. So people land in Singapore Changi. The furthest location is called Jurong Island. It takes about 1.5 hours by road. वो businessmen उनके पास time नहीं होता है, so they land there, take a air taxi, straight they can go to Jurong Island in a matter of 5 minutes or 10 minutes. So within 300 kilometer range, air taxis will be the next big thing. It is already there, it's just a market, it has not yet been introduced because of the regulatory issues and of the airspace, but that is going to come in a big way. Okay? So, and that is the top thing is it's a pilot study, 4 hours, I think from Australia to somewhere, they went on the electric aircraft. Okay? So this is what is the transportation system, transportation electrification we talked about. Next slide, please. So join the Power Electronics Society today and be empowered with so many things. The essential membership pricing, IEEE members, if you are an IEEE member, you want to join as a Power Electronics member, the price has dropped from $25 US to $10 US. Now coming to the student, it is just $5 US. अब पता नहीं इधर मैकडोनल्ड बर्गर कितने का कॉस्ट है, लेकिन मैं कंपेयर करता हूँ, सिंगापुर में एक मैकडोनल्ड बर्गर is about $5. So I tell the students, you sacrifice 1 day lunch, don't eat McDonald's burger. Take that $5 and join as a free member, as a student member. Then you can avail all the facilities. And if you join today, it will be free. Okay? Next slide. There are many things here. I am not going to go through each and everything. We have 290 chapters, like this chapter in Ahmedabad, this is a Gujarat section chapter, is one. 290 is a little bit outdated, now it is 310 chapters worldwide. Within India, we have about 12 plus, right, chapters. Different states have their own chapters. Conference workshop. आप अगर किसी भी conference में you join as a student member, registration fee, if it is $500 or $1,000, whatever it is, as a student member, student का cost काफी कम है, $300 US typically, registration fee, international level पे. You can get $50 to $75 with if you are an IEEE member and PELS member. Are you getting my point? आपने कितना दिया student membership के लिए? $5 US. You get $50 return. Then 10 years fees you have paid is already refunded back to you. Provided you are attending a conference, you have a paper to present. If not, you are not going to get that $50 repaid. You got my point? And those they are doing masters or PhD, you have to publish. Forget about the faculty member. If the faculty member don't publish, they know very well. You have to publish, otherwise you cannot keep your job. I'm talking about international market. Very true in India. 4 to 6 or attend 4 to 6 conference. For each conference, if you get $50, that is very, very good offer. Okay, next slide, please. So, fuel your career and future. Join the IEEE PELS today and be connected with the ultimate source of power in the industry. I stop here about the IEEE thing. Any question anybody wants to ask or clarification? To form a student branch chapter, you need only about 6 members. If you're IEEE member and there are 6 members, contact Dr. Priyesh. He will tell you how to form the chapter online. And once you form a chapter, what benefit do you get? You can invite not me, but somebody else to give a distinguished lecture. You don't have to pay much, except Priyesh has to pay for my local transportation. But my airfare to come here and give a talk is all taken care by IEEE Society. Why they have done it? They have done it because to promote PELS, Power Electronic Society. So there are only about 10 distinguished lecturers like me. They have been elected 3 every year, and we go for a term of 2. By God's grace, मेरे को 4 साल मिल गया है अभी. लगता है इस साल के end में मेरे को नहीं देंगे. क्योंकि I travel quite a lot and charge a lot of money from the IEEE Society. I mean, I fill up the other people's quota. They don't go, so I fill up their quota and take money. So I'm on the treasurer's radar screen. The Sanjib Panda, जिधर देखो संजीव पंडा इधर मैक्सिमम गया है, अभी साउथ अफ्रीका से आया है, इधर इंडिया जा रहा है. क्यों जा रहा है इतना? हमसे पैसा लेके. So I'm just joking, but I am on the radar screen that I am overutilizing. So they may cut me off. And the distinguished lecturer to give avenues to others. So to be a distinguished lecturer, you have to be nominated by the committee. And worldwide, only 10 people at a time will be the distinguished lecturer. Okay? Any other questions? Up here? People are wearing actually, so you are a volunteer.
No, sir. We are from our student branch.
Yeah. Our student branch, also IEEE का student branch.
Vishwakarma student branch.
IEEE
Vishwakarma student branch.
Yeah, IEEE, right? Yeah. Vishwakarma student branch, but that branch IEEE comes from IEEE headquarters. So you are an IEEE student branch or volunteer. Yeah. Good. Any other questions? Are you interested to apply or not? Are you excited?
Yes.
Yeah. So catch hold of PS Chavan. He will give you the code. Then the first year will be free. You don't have to pay that $5. Of course, Gujarat is quite rich. So many rich people are around. Yeah, $5 देने में कोई हर्ज नहीं है. लेकिन पहले साल माप में देते हैं. अगले साल से $5 लेंगे. ठीक है? All right, we move on to the next topic. Okay. Yeah, you keep it there.
Okay.
I'll restrict my movement, so you don't have to do much. So the next topic I'll go, introduction to transportation system and why it is not sustainable. I say that the present transportation system is not sustainable. Now I'm going to ask questions mainly to the undergraduate student. Why? Why it is not sustainable? Can you tell me why it is not sustainable? Do you agree with my quote?
Yes, sir.
Yes. Then tell me why.
Because most of vehicle are in present time are most of IC engine vehicles, and they are producing much carbon emission than.
हाँ तो करते हैं करने दो तो पिछले 200 साल से या 150 साल से कर रहे हैं तो और 100 साल करने दो क्या फर्क पड़ता है
But sir, global warming भी हो रही है.
तो ग्लोबल वार्मिंग होता है किससे होता है
कार्बन इमिशंस वगैरह, कार्बन डाइऑक्साइड और कार्बन मोनोऑक्साइड जो इमिट होती है उससे.
वो क्यों एमिट होती है
इनकम्प्लीट कंबर्शन या कंबर्शन. Petrol
internal
or diesel.
combustion engine में क्या यूज करते हैं? कौन fuel?
Petrol या diesel.
Yeah, so you come to the point. The point is the present transportation system is not sustainable because it is heavily dependent on fossil fuels. Okay, that's the answer. अगर क्वेश्चन क्विज में आया तुमने ये नहीं दिया तो 0 मार्क पाओगे. इधर उधर करते रहो. वो जो सांप बुश में है ना, इधर है किधर, इधर है इधर है इधर है, नहीं इधर है इधर मारो. So your points will be very to the point. When we had COVID, okay, examination has to go on. तो घर से स्टूडेंट लोग एग्जाम देते हैं. कौन कॉपी कर रहा है, किधर कर रहा है? आई एम नॉट सेइंग दैट एवरीबॉडी इज कॉपिंग. वी डिजाइन द क्वेश्चन. आप गूगल बाबा से बोलो, गूगल बाबा बताइए इसका आंसर क्या है, गूगल बाबा को भी मालूम नहीं है. क्वेश्चन ऐसे सेट कर देते हैं. तो एग्जैक्टली टू द पॉइंट एंड टाइम कंस्ट्रेंट. यू डिले हियर, इधर उधर ढूंढते रहो, सांप निकल जाएगा फिर. All right, move on to the next slide. So most of the present transportation is not sustainable. Why? Because it runs on fossil fuel and it is inefficient. And we will be running out of the fossil fuel not that long. About a month, little bit more than a month back, I was at South Africa, Johannesburg. So they have a museum where they show the fossil fuel when it started, 2.5 billions of years ago. And they have all the things they have found over the last 2 billion years. I was so fascinated to look at it. I teach, when I teach a drives course, I was giving our energy course कि आपके प्रिंसिपल साहब ने बताया था थोड़ी देर पहले कि how we human beings came to know about fire and how to control fire or how to generate fire. It is exactly the point. तो जब 2 स्टोन लेके फायर इग्नाइट किए एंड हाउ दैट इम्प्रूव देयर लाइफस्टाइल, आई वाज सो फैसिनेटेड. उनको बोलते हैं होमो इरेक्टर. ये बायोलॉजिकल टर्म है बट इतना मेरे ध्यान में नहीं था, लेकिन मैंने यूज किया. अब वहां पे देखा तो अरे होमो इरेक्टर, अरे मेरे को मालूम पड़ा कि अरे यही वाला ये यूज करता था मेरे लेक्चर में, मेरे को खुद को मालूम नहीं है. सो व्हेन यू गो एंड विजिट डिफरेंट म्यूजियम यू लर्न एनीथिंग. And they have a very pictorial graph. If anybody goes to South Africa, Johannesburg, see that museum. I forgot the name of the museum. So there is a need for evolving paradigm shift in the transportation sector. How much time we have? Because I deviate while I talk, so 1 hour may not be enough. 20 minutes. Right, by 5:30 latest. Is that okay with you people?
Yes.
Yes.
Okay, because I'm going to ask question now, few more questions. So the present paradigm shift, there is an evolving paradigm shift for the transportation sector to make it more efficient, or 30% से 90% तक, more reliable, safer, smarter. That brought me the word. I was in Arizona, Phoenix, Arizona, about 2 years back for a conference. Me, my wife, my daughter, we 3 were there. My daughter was very fascinated to try the driverless car. Hey, it was Google driverless car. नहीं, Tesla नहीं. It is a Jaguar. Tata का car. I forgot the name. What was the brand called? I mean, brand is Jaguar, but the name of the company is whatever it is. We tried. She tried from her mobile phone. Then car came, and it couldn't park properly in the lot. So it was a little bit awkward position. It was blocking the traffic from behind. तो लोग honk करने लगे. Western world में तुम honk किया तो it's an insult. India में तो बहुत जाता हूँ. Okay? So we went in. Something went wrong. Then the guy, पीछे से लोग करेंगे कि तुम रोड ब्लॉक कर रहे हो. You move on. We cannot move on because we are not driving it. It is up to the car, autonomous car. Then we panicked. It says that you exit. So हमने निकल गए. जैसे ही निकल गया वो लॉक कर दिया डोर and whatever. Yeah, maybe we didn't do something wrong, something we did something wrong. Ignorant people first time. So she said that we try one more time. And this time we make sure nobody parks in that car. We blocked it, so it parked. We went in. Driverless car. We were scared, honestly speaking. Not, I was scared, but my daughter was in the front seat, and me and my wife were in the back seat. And we were really scared. Zoom, zoom, karke lekhe gaya. Then I said that it's going to hit. Then we went one block where the conference was, and we wanted to come back to the same point, then take our car to drive back. Then we saw that the part of the road at the exit was blocked because they were doing some renovation work there. So half road, there was a cone there. मैं बोला इधर फंसी है गाड़ी निकलेगी कैसे? Then it came. I said it is going to hit the cone. It did little bit of adjustment and come out, and then zoom करके आया. So that is the reality. Smarter. So you can dial, the car comes, you go in. In Singapore, we are still on a trial basis in a fixed location in Sentosa or in Marina Bay Sand. If you have been there, Marina Gardens by the Bay, they have that one, but not in the public road. But it is going to come. But it will take a long time to come to India. I challenge all these car manufacturers. If you drive in India in driverless car, that's the day I'll believe it. Let's see how much of AI knowledge you need. Indian AI knowledge you need to put in. किधर से वो डॉग आया, कहाँ से बिल्ली आई, कहाँ से क्या आ रहा है? Very difficult. But it is already working. So the paradigm shift will be done through the electrification that is more environmentally friendly. No greenhouse gas emission. Next slide, please. This is taken from a paper. So ICE vehicle, that is called, the author called in transportation 1.0 or car 1.0. Okay, that is not sustainable. So you need to do a paradigm shift in transportation, that is the hybrid vehicle, that is transportation 2.0. This has already well proven track record 25 years back. That's not complete. Then you go to the dual fuel vehicle. Dual fuel vehicle means you have an internal combustion engine that charges the battery, but when it is stationary, you can plug in. Okay, plug-in hybrid, and that will go to the full electric. That means there are no internal combustion engine. This paper was published in 2012, around almost 13 years back. Okay? But very relevant. This I use in my teaching for electric drive course. Next slide. This is hybrid electric vehicle establishing the paradigm shift. Students, get ready for question. This is called the hybrid vehicle can be series, can be parallel, can be series parallel. This is the picture for a series combination. So you have a fuel tank, then that drives the internal combustion engine. Pay attention, okay? Internal combustion engine output, energy is available in what form? Yes, girl, you.
In mechanical.
Mechanical. To propel the car, what type of energy you need? No. What energy in what form you need to move the car? Kinetic energy, mechanical. You need mechanical energy at the end of the day to propel the car, correct? So mechanical energy is already available. If I take that and fix to the transmission thing, then that is how the internal combustion engine works, correct? But there is a problem with the internal combustion engine. So that mechanical energy we feed to an electrical generator. Agree? Electrical machine operating as a generator does what?
Converts mechanical energy into electrical energy.
Very good. So you do one-time conversion. Remember one. Okay? And assume efficiency is 90%. It will be higher, but just assume 90%. Then there are three lines. Three lines mean the generator, electrical generator is a three-phase generator. You know three-phase system, right?
Yes.
Sure?
Yes.
थ्री-फेज सिस्टम में कितना वोल्टेज है बताइए, आप बताइए. What is the voltage in the three-phase systems between line to line? 14 नहीं होता है, 15. Sure? वो लाइन वोल्टेज होता है या फेज वोल्टेज होता है?
लाइन
तो फेज वोल्टेज कितना होता है? कितना होता है? ये दिमाग में घुस जाना चाहिए भाई. नाउ इफ यू आर डूइंग इलेक्ट्रिकल इंजीनियरिंग 230 वोल्ट अप्रोक्सीमेटली, तो सिंगल फेज यहाँ पे सॉकेट में जो मिलता है वो 230 वोल्ट. बिटवीन लाइन टू लाइन इज 415. फ्रीक्वेंसी कितना है? 50 हर्ट्ज. 60 हर्ट्ज नहीं है?
इंडिया 50 स्टैंडर्ड 50.
Did you measure anywhere 50 hertz?
Like we know this is like
You take for granted. Google ने बताया कि 50 hertz, 50 hertz. Google और किधर का 60 hertz भी बताएगा. Okay, I'm just joking. 50 hertz. Fine. So we convert that three-phase AC into power electronic converter DC. वो diagram originally diagram wrong है. Dash alternating है. It should be other way. Alternating to DC. It is converted. I made an addition that dash white color में है, वो वहाँ पे था, लेकिन ये conversion में इधर shift हो गया है. So input is AC, output is DC. That DC goes into the battery to charge the battery. Agree? Yeah, you remember number one, 90% efficiency. Power electronic converter efficiency is how much? AC 90%. Clear? Remember, 2 times conversion. Mechanical to electrical, electrical to electrical. Then you charge the battery or you feed into the second power electronic converter. That converts DC to AC. अब इधर AC है तो इधर क्यों इधर उधर कर रहे हैं? इधर AC है वहां पे भी AC है, तो कन्वर्शन क्यों कर रहे हैं? Sorry? To charge the battery. Okay? If the battery is cut off, I have only this line. Then why do I need to convert? I have a three-phase AC here. Output is also three-phase AC.
So motor की requirement
will
क्या?
work on a DC itself. Auxiliaries of the electric vehicle will work on DC, so we need a battery to feed.
No, हम auxiliary का बात नहीं कर रहे हैं. हम लोग main propulsion के बात कर रहे हैं. You understand English, right? I can speak in English now. So I'm talking about propulsion, no auxiliary. तो वेरिएबल एसी करने से क्या होता है? कैसे? क्यों? नहीं, मोटर पे स्पीड कैसे चेंज होता है?
सर
सर
मोटर को कंट्रोल करने के लिए 4 पैरामीटर हैं: फ्लक्स, टॉर्क,
voltage and current. Don't go so deep. At a surface level. Why do you need a variable AC? He said that to change the speed. Why the variable AC can change the speed? Fixed AC cannot change the speed. Is the question clear?
yes.
Tell me. इधर करके
सर
no. हाँ, तो फ्रीक्वेंसी स्पीड कैसे चेंज करते हैं? Go ahead.
NS is equal to 120 F by P. So
Wow, very good.
if we change
That
the
is what I
frequency,
wanted.
if we change the frequency, then we change the speed.
Yeah, but we
Particular-
change the synchronous speed
Yes.
by changing the frequency. You got it? So that is why we need variable frequency. But that is the synchronous speed. That is not the motor speed.
we can change if there is a synchronous motor, we can change by synchronous.
मैं
If there is
induction
an
motor choose
if there is an
करूंगा।
induction motor,
हाँ।
we can change by V by F ratio.
नहीं, इंडक्शन मोटर का रोटर का स्पीड जो कपल है is different than the synchronous speed, or is it the same as the synchronous speed? Different. Why it is different? If it is different, how do you control? Okay, backbench. Yes, बताओ कौन बदल रहा था क्या? मैं इधर आगे पूछ रहा हूँ तो बैक बेंचर से नहीं पूछ रहा हूँ। बोलिए, why the rotor speed of the induction motor is different than the synchronous speed? Yeah, go ahead.
सर अगर रोटर का स्पीड और सिंक्रोनस का स्पीड सेम होगा तो रिलेटिव मोशन जीरो हो जाएगा।
हाँ।
रिलेटिव मोशन जीरो हो गया तो सर ईएमएफ इंड्यूस नहीं होगा,
हाँ।
तो रोटर में करंट इंड्यूस नहीं होगा, तो कोई टॉर्क प्रोड्यूस नहीं होगा, तो इंडक्शन मोटर चलेगा ही नहीं, तो स्पीड जीरो रहेगा। इसलिए सर हम रोटर की स्पीड को हमेशा कम रखते हैं सिंक्रोनस स्पीड से, जिससे कि रिलेटिव मोशन रहे।
तो कितना कम रखते हैं?
सर मतलब अगर
100 आरपीएम, 200 आरपीएम, 500 आरपीएम।
अगर सर सिंक्रोनस का स्पीड 1500 है तो 1450 जितना होगा सर।
1450।
1400 और 1450।
या बट मेरा कार अगर स्टार्ट हो रहा है तो आप 1450 आरपीएम नहीं चाहिए, मेरे को 10 आरपीएम 20 आरपीएम चाहिए। So we change the frequency. Anyway, the rotor speed NR is equal to 1 minus S slip multiplied by the synchronous speed. So that is the point I was saying. You change the synchronous speed, but it is the slip that it depends on the slip, the load, then the rotor speed will be different. Got it?
Yes.
Clear? You still remember two conversion? नहीं, अभी 4 conversion हो गया। वहाँ पे गया तो third conversion, and then variable voltage, variable frequency. Yeah, that's the question. Somebody was saying variable voltage, variable frequency, right?
Yes.
So frequency is the only thing that changes the speed. Why you need to change the voltage?
सर एक्चुअली जो फ्लक्स लिंकेज होता है अंदर, अगर वो एक्सीड हो जाएगा तो
तो
अंदर
फ्लक्स
डैमेज।
लिंकेज और स्पीड का क्या फर्क है? फ्लक्स लिंकेज हाउ डू लिंक टू द स्पीड?
अगर मोटर डिजाइन करी जाती है ना तो पर्टिकुलर एक लिमिटेड फ्लक्स के लिए डिजाइन करी जाती है
हाँ।
कि इस फ्लक्स इतना ही होना
हाँ जी।
चाहिए। अगर वो एक्सीड करता है तो फिर वो
नहीं, एक्सीड नहीं किया, उसको नीचे डाल दिया। एक्सीड नहीं किया, बट वी मेक इट 50%।
तो लिंकेज नहीं होगा उतना ज़्यादा
क्यों
आउटपुट।
नहीं? लिंकेज नहीं हुआ तो क्या फर्क पड़ता है? मोटर तो ठीक है।
मोटर आउटपुट नहीं देगा उतना।
यस, गो अहेड।
सर बेसिकली जो मोड में ऑपरेट करती है कांस्टेंट टॉर्क और कांस्टेंट पावर, सो कांस्टेंट टॉर्क के लिए हम वेरिएबल वोल्टेज वेरिएबल फ्रीक्वेंसी ड्राइव यूज करना है।
No, not true. Your torque will be changing, the power will be changing for a car as the operating condition changes. All right. So you need you need variable frequency to change the speed from stationary, accelerate, coasting, deacceleration. So the speed needs to be changed. That part is clear that you change frequency. But frequency change किया तो voltage क्यों चाहिए change करने के लिए? वो ये साहब बता रहे हैं कि फ्लक्स लिमिट से ज्यादा नहीं होना चाहिए। नहीं, मैं लिमिट से कम कर रहा हूँ, तो नो प्रॉब्लम। So the bottom line is, in the BH curve, the magnetic, you operate mostly at the knee point. Why? Because we want to maximize the torque is a function of the flux. So you want to maximize the flux, usage of the flux to the maximum limit. Okay? I can reduce the flux, but then the torque will be reduced. I don't want to reduce the torque. I want to maintain the torque. So I maintain the flux at its most optimum value below the knee point, and then use the other parameter, the current, Q-axis current, to change the torque. Are you clear?
Yes.
It can be variable torque, variable power, anything you want, I can do it through the control design. So you need variable voltage, variable frequency at the output. That is why from the fixed voltage, fixed frequency, we go to DC and then invert back into variable voltage, variable frequency AC. All clear? Yeah. Then you feed into the motor. Motor will convert the electrical energy into mechanical energy. And then feed into the vehicle to protect. So my question to you again, for red color generator 0.9, the first power converter 0.9, second power converter 0.9, motor blue color 0.9. 0.9 times 0.9 is how much? 0.9 times 0.9 is how much? 0.9 times 0.9 is how much? 0.81. तो 4 है 0.9, तो दूसरा वाला में भी 0.81 हुआ, तो 0.81 times 0.8 is how much? Take it 0.8 times 0.8, 8 times 8 is 64.64. So between this mechanical energy output of the IC engine
64
and there, your efficiency is 64%. So 36% already gone.
Yes.
Then tell me, how come the vehicle is giving 2.5 times more efficient fuel economically when you lose 36% here?
Regenerative braking. 21%, most 21% of power is comes back with regenerative braking, and
तो regenerative braking में क्या होता है?
sir, we are also using battery to
सर
मीटर
काइनेटिक
जोड़
एनर्जी प्रोड्यूस होती है ना, वो हम वापस से यूज करते हैं बैटरी को चार्ज करने के लिए, रीजनरेटिव ब्रेकिंग।
तो काइनेटिक एनर्जी क्या बैटरी को चार्ज करने के लिए यूज करते हैं? सिर्फ
वो reverse
गाड़ी को स्टॉप करने के लिए काइनेटिक एनर्जी यूज करते हैं। तो हायर स्पीड से लोअर स्पीड में गए आप mv स्क्वायर, करेक्ट? m v1 minus v2. If v1 is higher, v2 is lower, then you are basically extracting the kinetic energy to reduce the speed, converting it back through the motor to operate as a generator to get back electrical energy. That charges the battery. Okay? So उधर अगर 2.5 times efficiency बढ़ा था, इधर 36% we lost it. So do you think how much time you do brake that you can recover back all the energy? अब एक्सीलरेट किया, उधर गया, नेक्स्ट ट्रैफिक लाइट में ही ब्रेक करेंगे, और हाईवे में तो गया तो ब्रेक ही करेंगे नहीं, तो एफिशिएंसी कहाँ से बढ़ गया?
So here internal combustion engine works at a constant speed, and in normal vehicles internal combustion engine works at different speeds. That's why losses are more and here losses are more.
Alright, I'm glad. Two things. You decouple the internal combustion engine speed from the vehicle speed. Decouple. You operate the internal combustion engine at its most efficient point of 30%. Sometimes the vehicle may not need that much of power. You divert the power to the battery. Sometimes the younger generation, they want to overtake the old man driving the car at the front, okay, like me. So you need more power. You need more power. तो इधर से इंटरनल कंबशन इंजन में से दिए बैटरी से दोबारा एक्स्ट्रा पावर निकाले, जूम करके आ गए उसके सामने, वो बोलेगा कि ये ब्रेक मार देगा, मेरे को धक्का लगा रहा है। Agree? So you decouple the vehicle speed. So you are operating the internal combustion engine at the most efficient point. So you have surplus power, you store it. Regenerative power rather than a mechanical brake shoe pad hitting on the wheel, friction, that is heat. अब उधर कोई सोने वाला नहीं है कि हीट चाहिए उसको ठंडी मौसम में, right? You're not going to sleep there, right? Inside the car there. So that way energy is wasted. You know the energy can neither be created nor destroyed. It can be converted from one form to the other form. We don't need heat, but it gets converted to heat. Agree?
Yes.
So these 2 points makes the hybrid system more efficient. Very clear?
Yes.
Any doubt? Move on to the next. ये parallel का है, so you have a parallel mechanical energy, battery से भी parallel mechanical energy, then you can add on. Move on. Y series, Y parallel, we can have both, so it is series parallel. Next. So go on one by one. So one by one. Electric propulsion motors are more efficient and faster than mechanical hydraulic pneumatic system. 95%, 90% I took. Internal combustion engine is 30%, so 3 times more efficient. Next. The internal combustion engine can be operated at the higher efficiency operating region. Just now somebody pointed it out, I explained that part. Third, regenerative braking. So regenerative braking and decoupling the motor speed, the vehicle speed from the internal combustion engine speed makes it more efficient. These are the key points. The takeaway message is these two. If you go for interview anywhere, TVS, transportation, you have Tata, you have so many things, you better remember this point. Okay? Move on. This is plug-in or charger. उधर से stationary में you can charge it. Next. Yeah, go on. Yeah, move on. Next. Yeah, this is the EV completing the paradigm shift. This whole picture may you never find an internal combustion engine because everything is full electric. Somebody pointed out auxiliary load. You have the DC to DC converter 12 volt on the battery and other load. Do you know a normal internal combustion engine, Mercedes, BMW, how many electric motors or actuators are there in a normal car, internal combustion engine? What do you think? 5, 10, 15, 20. There are of the order of hundreds of electrical actuators. How? Driver seat, forward, backward, उसका backrest, inclination, तो 6 motors each seat के लिए होता है. आपका wiper, window, back screen, wiper, you add on all these things. They say it is about of the order of hundreds of electrical actuators. Even if the main propulsion is internal combustion engine. So when your main propulsion is electric motor, you have a central energy storage system that does whole distribution. Clear? Okay, move on. So that is about the present transportation system is not sustainable. We need EV. Not just on the road, in the air, on the sea. Singapore port is one of the busiest ports in the world. So when the ships come to load, unload the containers, if their engine is on, they pollute the port area. That is carbon emission, CO2, and that is will go against Singapore country emission. So what the government is now doing is, you don't come into my port, you stay away, half a kilometer away. You switch off your engine. I will send a tugboat, electric, that will drive you in. You park, it will unload, don't switch on, switch on your engine, will take you back. Once you are outside that half a kilometer zone, then you switch on your engine, okay, in order to reduce pollution. So we are working on a floating living lab. So these tugboats are electric. They need to be charged 24/7. So they go, bring it, then come to the charging station. You plug it in, high power charging, get charged, again go back. And even in the yard, when the big trucks, we call prime mover trucks, they transport the container from the ship to somewhere else to store it and then bring it back for loading, unloading. They emit a lot of carbon dioxide. So all prime mover in the Port of Singapore Authority, PSA, they manage it, all are electric now. Okay? So in the port area, it is clean, environmentally friendly. So the tugboat I talk about charging, it is a floating living lab, solar panel, gas engine, 2 gas turbine based engine, and 2 battery energy storage systems. The total load is about 20 megawatt or 21 megawatt. So we were involved in part of the thing. You left by then. Yeah, this is only in the last 4 years. So there was a company called Universe in China. They had been giving. We were a part of it. We did the contingency analysis. If the whole system blackouts, how do you start the power using the battery storage? And this is connected to the main grid. So when you don't need so much of power for the charging, then this will supply power for the grid frequency regulation and voltage regulation. So it is interconnected. You think about it, this whole living lab, which is floating on the sea, is a power plant of 20 megawatt. They have been anchored on the west side now. But tomorrow, if we have development on the east, on the south, the whole power plant can be unanchored and then move and anchor there. So it is like a movable power plant. That's the innovation that has been put in. So in the deep sea, when you go for oil exploration, this type of power plant can work there. And today, oil drilling is over, you go to the next, and that is the whole idea about moving power plant. I forgot where I was. Okay, now we go next. So we need a microgrid or a smart grid. Do you have anybody at this point? No. Energy grid 2.0 is on the left hand side, the blue color line. We thought that we are in grid 1.0, but Energy Market Authority, the recent grant call says that grid 3.0. So grid 2.0 is a little bit outdated now, but we don't have a smart grid as of today in Singapore. So the futuristic thing is that the conventional grid, blue color line, will be still there. Then they are all brought into a smart grid, the red color line that you see. The red color line is the electrical power, and the dashed blue color line is the communication network. Okay? So we are developing a smart grid within our campus called dual distribution systems, AC and DC. So in future, what will happen is, if you have a renewable energy source on the top, that is the wind turbine, that goes through a square box, black color, like the conventional one also through a square box. Those square boxes are called energy control center. So all AC DC power must process through a power electronic converter, which is called as the energy control system. That connects to the smart grid. Then the load are industrial load or a some microgrid, or this is residential load or PV generation. All are interconnected there. That forms the microgrid. Microgrid can be grid connected, grid islanded. I'm not sure, in India, do you have a microgrid already? Not yet, right? At the research level, yes. So in Singapore also we don't have it. In a Pulau Ubin island, there is a small microgrid, but we are trying to do it in a bigger scale, about few megawatt within the NUS Kentridge campus. Okay. So objective of the energy control center, this is going a little bit deep dive. Okay. Undergraduate students may or may not understand, but it is a little bit deep dive. Active power flow control and its compensation. How many types of power you are aware of? Tell me.
Active, reactive, apparent.
Active, reactive, apparent.
And
Active, apparent.
what is the difference between the three?
एक्टिव पावर जो होता है
Yeah, go ahead.
एक्टिव पावर जो होता है वो ट्रू पावर यूजफुल पावर होता है. एक्टिव पावर जो होता है वो यूजफुल पावर होता है जो सर्किट में एक्चुअली यूज होता है. जो रिएक्टिव पावर होता है वो इमेजिनरी पावर होता है, और जो अपरेंट पावर होता है वो एक्टिव पावर और रिएक्टिव पावर का दोनों का कॉम्बिनेशन होता है.
तो इमेजिनरी पावर क्यों जरूरत है? इमेजिनरी है ना, वो यूजफुल नहीं होता है, और रिएक्टिव पावर यूजफुल है.
फॉर
It doesn't do any work.
for creating magnetic field.
Magnetic.
No, but does it do any work?
No, it just create magnetic
No,
field.
does it do any work? Yes or no?
No,
No. Then why do you need it?
because without magnetic field, how can you induce?
तो मैग्नेट डाल दो वहाँ पे, वो मैग्नेटिक फील्ड हो जाएगा. Why do you need reactive power? If I have a magnet to create a magnetic field, right? I bring a magnet. So why
But
do
it-
I need reactive power?
If in alternating, then if you want alternating, then in case of AC,
तो उसको रोटेटिंग बना दो. रोटेटिंग मैग्नेटिक फील्ड वो ऑल्टरनेट करता रहता है. करता है नहीं करता.
Sir, but transformer does not have rotating parts.
So it doesn't produce rotating magnetic field.
How it will should?
How it will produce? Transformer operates on AC, correct?
Yes.
If it is AC, it is alternating. So positive, negative. So magnetic field change हो रहा है.
Sir, but magnetic field बनाने के लिए भी reactive power चाहिए.
Okay. We can go on debate. Anyway, active power is the useful power. Okay. So what I'm saying there is active power flow to do the work. Var is the reactive power. Okay. It is needed, but it doesn't do any work. It's imaginary. Then we can have another session to discuss about why do you need reactive power. Okay. Harmonic compensation. In harmonics, what is harmonics?
Unwanted
disturbance.
signal,
Unwanted signal.
signal and disturbance in sinusoidal.
Yeah. So do you need harmonics? You don't need harmonics. Why? It is unwanted. That's why you don't need it. Yeah, but why do you get it? If it is unwanted, why do you produce it?
When we use the power converters on and all that.
नहीं, हार्मोनिक्स वोल्टेज ड्रॉप नहीं करता है, डिस्टॉर्ट करता है. तो इट में गो अप, तो इट में गो अप, so it will be higher. Harmonics do not contribute anything to the useful power. Okay? If you study through the heavy power course, harmonics do contribute to increase the RMS current. RMS current, when it increases, I square R loss increases. But it does not, when RMS current increases, it does not increase the output power. Remember, that topic is very deep. We are not discussing here. Harmonics unwanted, okay? But it comes because of the power converter on non-linear load. They will introduce harmonics. So how do you mitigate? Those things will be there. Microgrid control, islanding, grid connection, information sharing between microgrid, rest of the power network, all these things are the role of that square boxes, energy control center. Next slide, please. This is the microgrid. वो जो रेड कलर का मीडियम वोल्टेज जो आर्क देख रहे हो, वो ट्रांसमिशन लाइन से मीडियम वोल्टेज से आता है. इंडिया में व्हाट इज द मीडियम वोल्टेज? What voltage your substation you get the voltage? Do you know?
66.
66 kV or 220 kV, whatever it is. Okay. Then you need to step it down. Okay. To low voltage. Low voltage is that 415 volt three-phase system we are talking about. Then it goes to the microgrid and the low voltage side. So you need to interface the medium voltage AC grid connected system in the microgrid. Next slide. Okay, move on. Okay, now pay attention. The top one is a conventional on-load tap changer transformer. This is your topic. It is quite robust. Power flow it can control, but it is red color. Can you read it? Red color, right? Discrete. And unidirectional. I won't say it is unidirectional. Power can flow in both directions, but it is usually from the primary to the secondary side, and is discrete. If I need to change the power level, I need to change the power flow control. I need to change the voltage to the on-load tap changer. So I cannot control continuously. I can still 0.8, 0.6, something like that at certain stage. That's the drawback. And it is a low frequency isolation. So you have a transformer, primary and secondary are isolated, correct? What is the frequency of the line frequency transformer? Is 50 hertz.
50 hertz.
It is called as a low frequency. Okay, 50 or 60 hertz. So what is the drawback of a normal transformer? Of course, the red ones are the drawback. The green one is the positive part. Now, आप लोगों के यहाँ पे काफी जमीन है. You can have a substation at the ground. सिंगापुर के पास जमीन ही नहीं है. तो अगर ये वाला hall या आधा, a substation typically will take 3/4 of this hall. 3/4 of this hall, if I sell in the property market, will be few $1 million. Get my point? So why should I have the substation at the ground? Because of the bulky transformer, switchgear, everything. If I can shrink the size and the weight to lower value, I sell this land to a property owner. He will build a 100-story building and he will give me $5 million, let's say. Then this substation, if it is lighter, we can take to the top of the building. So each building can have a substation. Then land, we make it free for other purposes. Got it?
Yes.
That is what is called solid state transformer. You have seen the analogy of that one in your laptop. Are you using a hard disk drive or a solid state drive?
Solid.
Yeah, then answer the question. Why not hard disk drive? What is the problem? It was rotating, wear and tear. Of course, our transformer is not rotating, it is fixed, but it is bulky. And and the other problem is, if I want to interface DC, like I have a PV, how am I going to interface DC with a normal transformer? Cannot do it. Unless the light color thing you see, AFE rectifier, that is active front end rectifier, that converts AC to DC. Then I have a DC link that goes to the LVDC. And then if I need AC, I go through the inverter to produce LVEC. Then once I have a DC link, I can interface the battery storage system, I can interface the PV, or I can interface the wind, renewable energy. So I can do all these things, but with additional things. Next. This is called solid state transformer. If I increase the frequency from 50 Hertz to 50 kilohertz, 1,000 times more, I can shrink the size of the transformer. Not in the same ratio 1,000 times, but in a non-linear way about 10 times. Size and weight. That is why if I can reduce the size and weight of a transformer by 10 times, I can put it on the top of the building. And that is why Singapore has invested heavily on this thing, and we have a startup company by one of my former PhD student, Anshuman Tripathi. The name of the company is called Ampere Sands. They have demonstrated 6.6 kV to using solid state transformer to LVEC. But that market is growing. I heard in India, Delta Electronics has introduced a product with IIC Bangalore, Postic Bosses Group. They have solid state transformer. It is coming up, but not commercially used. So reliability, robustness, it is a problem. Yeah, the other point I missed. So when you, I told about this. When you increase the frequency, you could reduce the size and the volume. Then you have a back-end converter to convert high frequency AC to DC. High frequency AC to line frequency AC. Then you will have LVDC, everything. So solid state transformer will be the future in years to come. Hold on. Next. Yeah, move on. So there are different architecture. I'm not going details of it. Let's move on. Yeah, I'm going to the futuristic universal EV fast charging station. The basic point, let me clarify here. Charge, how do you define charge? Not definition, what is the equation for charge, Q, as a function of I and T? I is the current, T is the time. Say it again.
I is equal to Q by T.
I is equal to Q by T.
dq by dt.
Integration of I dt.
Okay. Q is integral I
dt.
dt. Or in short, if I is constant, I times T. Q is equal to I times T. Clear? The charging station battery needs charge, Q. Clear? What is the problem with the charging station now? It takes a long time. Correct? No, that's just the mind, that's not the reality. You increase the current by 10 times, you reduce the time by 10 times. So we can have fast charging station that can charge 1 by 10th time. Then I can have on the highway charging stations. So you're driving highway, I don't know which highway it is nearby. So you plug it in, go for a cup of tea, restroom, 15 minutes. Yeah, timing never finishes. 10 minutes. Because I have other appointment to go. So remember, Q is equal to I times T. If I increase the current, I can reduce the time. So it is not a problem. Fast charging. Next. This shows you line frequency transformer isolation, or you can get isolation in the DC to DC stage, which is the part of the SST on the second graph. Okay, but the second B graph has medium frequency transformer, so the size is reduced. Then you have the battery at the end. This is, you multiply multiple things so to increase the power rating. Next. So if you go for the first scheme, MV AC to LV AC, that is the AC line, you integrate PV, DC to DC converter, DC to AC converter, then you integrate it there. And to charge, that AC is converted to DC, then DC to DC converter, then you fit into the charge. If it is AC connected. If it is DC connected, I replace the AC, DC, DC, AC all converter into one yellow box, AC to DC converter in the front end. Then I can interface PV through a DC to DC to the DC bus. I can interface from the DC bus, DC to DC converter to charge the car. And energy storage system. Okay? That can be a comparison between the two. क्या क्वेश्चन है बताइए? नहीं? आपको बता रहे हैं, आपको भी बताइए? नहीं? क्यों? बताओ ये आप लोगों को भी knowledge gain करना है. You have a doubt? You ask me? No? All right. I'll be finishing up 10 minutes time. Next slide. So this side is lesser conversion stages. We have replaced so many converters to less number of converters. It is a higher efficiency, it is a simpler control, but protection mechanism in a DC circuit is a topic of research. That may be one of the problems. In AC, the current goes through zero every half cycle. We can interrupt it at that point. But DC current is constant. So how do you protect it? Then DC protection mechanism is much more complex. Next. Okay. You pay attention on this side. There is vehicle owner or there will be station owners. Their requirements are different. The vehicle owner would like how to charge the car within the shortest possible time. Fast charging, and if I drive into a charging station, there must be a slot for me to charge. If there is already a queue, I cannot charge. So then you bring in that location with GPS coordinate, figure it out which charging station is free. You can lock it and then go there, that slot should be available. So a lot of smartness can be built in from there. Higher availability, cheaper charging, okay? That will require reduced system size and higher efficiency. Now the station owner would like, it is cheaper to install, the better site utilization and higher revenue. Their requirements are conflicting. So when you design the system, you need to optimize looking at the different requirements. So it is a multi-objective optimization problem. Next. This is a little bit beyond your scope, undergraduate student, but this is a charging station. On this side, NBAC, maybe 6.6 kV or 22 kV. That converts into LVDC. Then LVDC is again through a DC to DC converter. On the top one, you see big buses, trucks. HPEV, high power plug-in electric vehicle. The medium, the middle one is medium. I cannot read it properly. Anyway, that's the medium plug-in vehicle charging, and the bottom one is the low plug-in vehicle charging. Okay, so the charging stations are all universal. Like nowadays, you go, if there is a petrol pump, you go petrol, or another one is diesel, you go diesel. You cannot change. But with this universal charging station, it might be possible. Different vehicle can charge from the same station, different power rating. Okay. Next. Don't worry about this. So that is the charging current and state of charge. So the blue color graph is the state of charge, goes from 0 to 100%, and at different level you have a different constant current, load constant current, then it reaches about 90%, then you charge at constant voltage. So it's a constant current, constant voltage charging mechanism. Then you charge up to 100%. Clear? Discharge, again, multi-stage constant current, constant voltage discharge. Next cycle. This is what we built for 13.2 kVA. The researchers built in the lab environment, and experimentally we validated everything. Next slide. Okay. The one I showed you, constant current, constant voltage charging, discharging. The top one is for high voltage, high power, medium power, low power. Charging, and then it is discharging. Okay. We can move on to the next one. Why it is so? The problem with the projector, not my slide. Okay. So this shows you the time domain characteristics when you change step reduction in the power 100% to 40%. G to V. G to V means grid to the vehicle. Alright, grid to the vehicle. Now you think in future when you have millions of cars all connected to the grid. Okay, they are stationary, all connected to the grid. You can transfer power from the vehicle to the grid. So the power transfer is bidirectional, G to V, or it could be V to G. If it is V to G, you program, I want my power to be discharged to 30% because last 10% I need to go back home, otherwise I will be stranded. Then you can program in the stock market, जब शेयर वैल्यू इतना हुआ तब बेचो, जब उससे नीचे है तो बेचना मत. Means you don't sell the charge to the utility unless the price is right. You program everything. Automatically the charger and the grid will do the handshaking and transfer the power. Okay. What benefit we get? We have millions of cars. then they can support the grid, voltage regulation, frequency regulation. The grid scale energy storage, which is expensive, need not be needed. Agree? So you can play with the grid like in a stock market. Next. Now you talk about efficiency. The blue color line is the efficiency. I will flip. 88% to 96%. So we have got efficiency at 13 kVA about 96.3% efficient. Okay. Below 80%, nobody will buy. 96, 95 and plus. If you go for high power one, megawatt level, you can go up to 98. The red color graph is the THD, total harmonic distortion. Higher the distortion, higher will be the problem. So we make sure that it is below 5%. We are below 3%, which is well and good. How you achieve that? With red. Intelligent control, you do it. Modulation. Next. Yeah, we compare with ABB, with Tesla, with Delta, all these things. And the last one is our. Can you click one more time? That is our. There is a color showing there. You pay attention that 1, 2, 3. 3 from the bottom, 96.4% the peak efficiency we have achieved. That is much better than 94, 94, 94, 93, 96. So we are better compared to all these commercial vehicles. Charger. Power density, the next one is 3 kVA per liter. Power density. Okay. Here it is 0.07, 0.2, 0.14. We are almost 2 orders of magnitude better. Okay. And charging time, 50 minutes for large power vehicle, 28 minutes for 2 medium vehicle, and 16 minutes for low power vehicle. That if you go for high power, that can be reduced. Q is equal to I times T. I increase current, I can reduce the. All right, next. 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 Final. So compared to the conventional line frequency transformer based solution, SiC is a silicon carbide based wide bandgap devices. The inverters are all designed based on that one. And we have interfaced MVAC to the LVDC conversion. SST provides a competitive edge in the EV fast charging stations involving MVAC to LVDC. Futuristic universal EV fast charging station, it can provide bidirectional power flow, grid to the vehicle, vehicle to the grid. Both can be done. And offer superior efficiency power density compared to the other fast charging products. Next. Okay, all the work I didn't do, several PhD students have done over the last 10 years. But this is the last one, Jaideep Shah, he's a Bengali from West Bengal. So he's still in Singapore working for ST Engineering for high altitude satellite power system design. This is basic. All my students, I put them to work for me after PhD for 2 years, like postdoctoral fellow like PS joined me. There was a time when you were there, I had a team of 45, 15 PhD plus 10 postdoctoral fellow, master's student, all inclusive. Again, people complain against me. How come this guy is taking 15 PhD students? How much time he spends on each student? My philosophy is very clear. I, as a supervisor, define your problem statement. It is you are getting the PhD degree, you work for it. Of course, I guide you. Defining the problem of the PhD is the major hurdle. Once you have defined it, That is not for yesterday's problem, not for today's problem, but 10 years down the road. When we did all this thing, industry was not ready to take it. Because from the research bench, it comes to the industry, there is a gap of about 10 years. Even in the fast changing world, it takes 10 years time. So now we see the solid state transformer as a product. But this research we have started about 12 years back. And these are all the publications of Jaideep Shah and some journal and the other thing. That's the last slide, I guess. Next. Yeah. Thank you very much for your attention. I'll be happy to answer if you have any questions. But if you're hungry, you want to go, that's also okay. Yes, any questions? No question? So when there is no question, there is a joke about it. When no question means everything I talked about went above the head, like a tangent. So nothing goes inside. But the first part and the second part is very basic. We interacted. And that is what is the role of the DL, to interact with the student. And we pitch it at the right level. So that's why I asked Priya, who are the audience? Undergraduate, faculty, or research student? Then we pitch it accordingly. Some part I had added on the middle part, which is for the undergraduate student. This is from my lecture note I teach to the undergraduate student. Last part I left it, that is solar assisted PV charging station, solar PV assisted charging station, where you don't use a storage device, but yet make the grid compliance, the ramp rate and everything. So that part I had excluded because you cannot follow that part. Yes, please.
सर जैसे चार्जिंग बैटरी चार्जिंग के लिए जो ग्रिड टू व्हीकल है उसमें करंट कांस्टेंट स्टेप्स में जा रहा है, उसकी जगह कंटिन्यूस क्यों नहीं कर
सकते हैं, but you need to maintain a particular current. Yeah, it's a good question. It can be done like that instead of steps. You could make it continuous, but then your control system will be much more complex. But here you have few discrete steps. So जब चार्ज इसके बीच में अंदर है, तो this is the charging rate. Of course, you would like to make the charging rate as high as possible so that you reduce the time. But there is again battery chemistry, which is very non-linear. So you have to take that into account and then design the charging steps.
सर अगर नंबर ऑफ स्टेप्स बढ़ा दिए हमने तो हमारी
Yeah, possible. But number of steps बढ़ाया तो your control system and the changing in the current on the power converter will be stressful. So there are multiple things that needs to be looked at. Yes, please.
आपने बोला सॉलिड स्टेट ट्रांसफार्मर में आपने फ्रीक्वेंसी बढ़ा दी, तो आपने इनपुट साइड से फ्रीक्वेंसी बढ़ाई या मटेरियल चेंज कर दिया?
इनपुट साइड से फ्रीक्वेंसी बढ़ाएंगे कैसे? It is connected to the grid.
यस सर, वही मैं बोल रहा हूँ.
The grid frequency is fixed 50 Hz.
तो आपने बोला कि एसएसडी में फ्रीक्वेंसी इंक्रीज कर देते हैं.
हाँ.
इसकी वजह से साइज कॉम्पैक्ट हो जाता है.
Right.
तो कैसे?
तो कैसे करते हैं? That's a good question. When you have a three-phase system, 50 Hz, you convert to the front-end converter from three-phase to single-phase. Okay, but that single-phase frequency is 50 kilohertz. So that is the modulation scheme and the gating signals that you do. That will change the frequency. Variable speed drive. तो आउटपुट फ्रीक्वेंसी चेंज होता है, राइट?
दैट मींस वन कंपोनेंट ऐड करना पड़ेगा ना सर आपको, पावर इलेक्ट्रॉनिक्स कंपोनेंट.
हाँ, तो बीच में है ना आपका, फ्रंट एंड में है कन्वर्टर, रियर एंड में भी कन्वर्टर है.
आपने कोर के मटेरियल को चेंज नहीं करा?
हाँ, वो मटेरियल भी चेंज करेंगे.
चेंज करना ही पड़ेगा तो.
यस, यस.
प्लस ना देगा.
What is the material we use? The materials are different. Okay. Are you clear about that?
Yes.
So three-phase to single-phase conversion through the power converter. line frequency to high frequency 50 kilohertz. Then I have a transformer 50 kilohertz to 50 kilohertz. But 50 kilohertz I cannot put into the grid. So that 50 kilohertz single phase system is converted back into 50 hertz three phase system. Then you inject into the grid. Clear?
सर हाई वोल्टेज आ रहा है, हाई वोल्टेज 50 हर्ट्ज पे आ रहा है, तो वो 50 हर्ट्ज को 5000 किलो हर्ट्ज में कन्वर्ट करने के लिए पावर कन्वर्टर लगेगा।
Correct.
और हमारा वोल्टेज लेवल हाई है, तो उसके लिए भी बड़े पावर कन्वर्टर्स लगेंगे, और वापस रिकन्वर्ट करने के लिए वापस बड़े कन्वर्टर लगेंगे। नॉर्मली ट्रांसफार्मर यूज करेंगे, उससे मतलब पावर कन्वर्टर्स दो बड़े बड़े यूज कर रहे हैं, फिर बीच में ट्रांसफार्मर आ रहा है, उसमें लॉसेस भी होंगे और जगह भी ज़्यादा लगेगी। उससे अच्छा डायरेक्ट नॉर्मली ट्रांसफार्मर यूज कर लिया जाता है।
और ट्रांसफार्मर का साइज
नहीं सर, पावर कन्वर्टर यूज कर रहे हैं तो उसमें भी साइज तो बढ़ी जाएगा।
साइज का अकाउंट करके the total reduction in the size will be about 10 times, including the power converter and the medium frequency transformer. So the size of the medium frequency transformer will go down by 10 times, 10 or 15 times, whatever it is. Power converter space requirement and the volume will increase by 5%. So overall, your reduction by 10 times.
कूलिंग सिस्टम रिक्वायरमेंट ज़्यादा बढ़ जाएगी ना फिर।
Yeah, देखिए तो करेंगे उसके लिए भी You know, the joke about power electronics people is they suggest you will increase your efficiency 98%. You increase, but then you create problem about harmonics. बोलते हैं हार्मोनिक्स प्रॉब्लम होता है, कोई बात नहीं है, मेरे पास आओ, मेरे पास और एक कन्वर्टर है जो हार्मोनिक्स को निकाल देगा। So this is the business model. You introduce something to improve something, but create on the side effect कि ये मेडिसिन लो तो तुम्हारा कैंसर ठीक हो जाएगा ना, कैंसर ठीक हो जाएगा मैं मतलब टकलो हो जाऊंगा, और टकलो हो जाएगा तो फिर दूसरा मेडिसिन लो फिर मरूंगा। I'm not joking about it. I'm just giving an analogy. Sorry, nothing, not right for me to give that comment. Okay, clear?
Yes.
क्या भाई फ्रंट बेंच वाले क्वेश्चन पूछते हैं, बैक बेंचर क्या कर रहे हैं? When I take a lecture, हम लोगों में बड़ा ऑडिटोरियम होता है, कभी लेक्चर अंडर ग्रेजुएट का 400 स्टूडेंट होते हैं, तो from my experience I'm telling you, your principal gave you a lot of advice. My advice after seeing I'm already 60 plus, last 40 years of getting involved in life, in power electronics or in teaching, I go around. So I go to the back side and see who is doing what in the first post. Then वो लोग फिर बंद कर देते हैं, फिर इधर आया तो फिर चालू कर देते हैं. That's the pen. I cannot change your mind, but we try our best. But I stop. उधर से gossip करेंगे, I stop lecturing. And everybody looks at why he's not talking. And the other two guys who are gossiping, their noise is more louder. And everybody, whole class will look at you, what are you doing, guy? Stop. So that is how we stop. Younger generation think you are smart. There was a WhatsApp message few days back. The old man was telling his old people, this is the McDonald's drive-in. You must be having here, right? So you order, you drive in. So पीछे वाली ये old man है, he was little bit slow in responding to the order. तो पीछे वाली जो गाड़ी में कोई young lady थी, वो ऑन कर रहा है, ये है. So somehow that I didn't get the point, but he ordered for the lady behind, or lady behind ordered. He go to the next counter, he paid for both the thing, and उसने जो order किया था और उसका भी दोनों लेके चला गया. तो आके बोलता है उसके दूसरे लोगों कि ये लोग सोचते हैं कि हम लोग से स्मार्ट है. मैं उसको ऐसा जो सबक सिखाया कि उसका खाना लेके आ गया, तो वो बोलेगा कि उसका आपका खाना तो लेके आपका दोस्त. So he has to again come back to the back side and again go in the queue. And that was really fascinating joke. Anyway, there are always differences between generations. But my advice to you is be an honest person. Don't take shortcut in life. You may take a shortcut, 5 मिनट पहले पहुंच जाओगे. But you may take a shortcut, वो 5 मिनट में 2 मिनट में you go hell or you go heaven. So never take shortcut. I'm talking about driving. Don't drive too fast and all. In life, take everything in the right approach. It may take a longer time, but you are not tensed. Okay, I'll lose this thing or I'll lose that thing. The moment you start doing wrong things, at least from my experience, you drain a lot of energy in thinking about the wrong thing. It is better to do the right thing, let it be slow, rather than wasting your time. And if you have a conflict in your mind, resolve it. वो गर्लफ्रेंड है या बॉयफ्रेंड है जो भी है रिजॉल्व कर लो उसी दिन, नहीं तो सोने के लिए मत जाओ. सोओगे तो ड्रीम में भी आएगा वही प्रॉब्लम. And this is what happens to me when I go to the lecture with 400 students. If a concept is not clear in my mind, I cannot sleep that night until that concept is clear. I may refer to 10 different books to get the message clear. And this happened for the principle of rotating magnetic field. As a student in Surat, हम लोग एक था टीचर थे अरोरा करके इलेक्ट्रिकल मशीन में. Do you know? Yeah, he chose a book Kostenko electrical machine. But the people hate it. You know, Kostenko Russian author book समझ में नहीं आ रहा है कुछ भी. Then उन्होंने उसको choose किया तो we hate electrical machine. Unfortunately, in later part of my life, I ended that I have to teach electrical machine. And when I have to teach rotating magnetic field, मेरे senior जो educator award पाए हैं, devote, I don't know him or not, but anyway, he tells Sanjib, don't go so deep, just tell at the surface level. But मेरे को जब समझ में आ गया, तो मैं सोचा कि मैं I must teach it. I must make sure that the student understand it. He said that it will backfire. You'll get a very bad feedback. And I got bad feedback. But that didn't stop me. But because I had to teach, I have to make my mind clear. And I'll tell you, 80% of the people teaching may not be clear about this concept. It is not written in any book. It is through your own understanding. Slayman, करके एक book है electrical machine. If you refer to that book, the torque produced in an electrical machine is very, very simple. The magnetomotive force of the stator and the rotor and sine of the angle between the two. So the question I asked, why the induction machine cannot rotate at synchronous speed? Somebody answered here. Because if both rotate at the same speed, relative velocity is zero, E equal to BLV. If V is zero, E is zero in the rotor. If E is zero, the current and the rotor is zero. If the current is zero, the rotor MMF, ampere turns, current multiplied by the turns becomes zero, then the torque is zero. Very simple. Cause and effect. So when you go for electrical machine, when I went for Bharat Bijli for my interview, there were questions like this. वो इधर उधर करके निकल गए, somehow they got it. But when I have to teach 400 students, question can come from any direction. And if you are not confident, it is wrong. Better to say, I don't know. I will revisit this issue after a while. So the bottom message is, be true, be honest, even if it takes a longer time. But you will win at the end of the day. Don't take shortcut because somebody else has taken a shortcut and you think that you will win the race. No, they will fail somewhere. All right? Thank you very much for staying back and appreciate it. Has somebody taken a picture of the whole class? From this side, this side. You need a report and it is very, very well attended and thankful to you. We will publish this in the IEEE Power Electronics magazine. I had spoken to Priyas, and when it comes 3 months, 6 months down the road, your institute name, your photograph will be there. That will be circulated worldwide. Okay? Thank you. Have a nice evening. Go ahead. Anything else?
Thank you, sir, for such an enlightening and technically enriched session. You really helped us by showing how to implement our fundamental formulas to real life, and how basics can help us in contributing and really huge innovation. So, as we approach the conclusion of today's program, I request Dr. H.D. Mehta to kindly present the vote of thanks.
Respected Sanjib Panda sir, esteemed faculty members, and my dear students. As we come to the conclusion of this highly enlightening expert talk on EV fast charging and discharging, it is my proud privilege to propose the vote of thanks. First and foremost, on behalf of Department of Electrical Engineering and the IEEE student branch, I extend our deepest gratitude to Professor Sanjib Kumar Panda for gracing us with his presence and for delivering such an insightful and inspiring lecture. Professor Panda's ability to seamlessly connect cutting-edge research with the real-world applications, especially in the emerging domain of electric vehicle fast charging infrastructure, has greatly enriched our understanding and broadened our perspective. Sir, we are deeply honored by your valuable time, guidance, and thought-provoking insights. I would also like to express our sincere gratitude to our Honorable Principal, sir, whose constant encouragement and visionary leadership makes it possible for the institution to host such academically enriching events. Thank you, sir, for your unwavering support towards fostering a culture of research and innovation. My heartfelt thanks also goes to the head of the Electrical Engineering Department for his continuous guidance, motivation, and for providing the necessary academic support to organize this expert talk successfully. I would also like to extend warm gratitude to Professor Priyesh Chauhan, sir, for sharing insights. And he has played a pivotal role in organizing this lecture. Without his support, this session wouldn't have been possible. A special word of appreciation goes to all the faculty members and students of Electrical Engineering Department, whose efforts behind the success have contributed significantly to the smooth conduct of this program. I would also like to thank the faculty members and students of IEEE student branch team for their enthusiasm, dedication, and meticulous planning. Your teamwork and commitment played a crucial role in coordinating this event and ensuring its success. Finally, I thank all the participants, students, and faculty members for your active participation and thoughtful engagement, which made this session truly interactive and meaningful. Once again, thank you, Professor Panda, sir, for an inspiring session, and thank you all for being a part of today's program. Thank you.
ये साइड से जाना है
Sorry for taking too much time. No, sir, it's fine.
मेरे को भी मेरे पास